This is the NEET 2018 question on waves. Question is like this. A tuning fork is used to produce the resonance in a glass tube. Length of the air column in the tube can be adjusted by variable piston. At room temperature of 27, two successive resonances are produced at 20 and 73 centimeters. Let's understand the meaning of this part of the problem first. What he's saying is, there is a tube, glass tube, which is filled with water. So the part above the water behaves as if like it's a closed tube. When a tuning fork is placed above to that with a certain frequency and send waves, that wave in a least possible way go this way and returns back. When the frequency of the tuning fork equal to the frequency of air column, they together vibrates with a larger sound, booming sound, that is called resonance. So when first time it happens, it's the least possible way. Here is a formation of a node. Here is a formation of antinode. So the length of the air column is distance between them, that is lambda by 4. Distance between node and antinode is lambda by 4. So lambda 1 could be written like 4L. Now I can write further the next possible way of vibrating the string, that is the first possibility. The same closed pipe can happen in this way, in such a way that sound can go this way and return back this way. This is one more possibility. This is where the next resonance comes. Here is a formation of a node. It's a formation of a node. Here is a formation of an antinode. So the length of this closed pipe is, distance between node and node is lambda by 2. Distance between node and antinode is lambda by 4. That is, 4 is the LCM. 2 lambda plus lambda, 3 lambda by 4. So that's the wavelength 1. Wavelength for a first resonating length L1. So I can write L1 equal to lambda by 4. We call this as wavelength lambda. Next time L2 could be written like 3 lambda by 4. Then when I write L2 minus L1, so lambda equal to 4L, L can be written like, L1 can be written like lambda by 4. So L2 minus L1 can be written like 3 lambda by 4 minus lambda by 4, that is 2 lambda by 4, that is lambda by 2. That implies wavelength lambda equal to 2 times of second resonating length minus first resonating length. So I can write velocity equal to n lambda. Velocity of the sound is n. In the place of lambda I can write 2 times of L2 minus L1. So velocity is 2n is L2 minus L1, where L1 is the first resonating length and L2 is the second resonating length, is the formula that we can use while we are using a resonance column apparatus experiment, and that's what he is actually talking about. Now look at the data. If the frequency of a tuning fork is given for you at a particular temperature, what is the velocity of the sound is? 2, n is given for you 320, L2 is 73 centimeters, L1 is 20 centimeters. Converting centimeters into meter becomes into 10 power minus 2. So 2 into 320 is 640. 640 into 10 power minus 2 is 6.4. 73 minus 20. So if you calculate this value, it becomes approximately 339 meter per second. Who is the answer for the problem? That's how we get the answer, right? We have already solved this kind of the problem earlier. This is a repetition of that model. And the only important thing that you need to know is, how do you get the velocity of the sound formula in a resonance column apparatus? And to make it convenient for you, I have derived it for you. You can use that derivation so that it will become easy to understand this kind of questions. Thank you for watching.